question 22 says the graph shows the variation with time of the displacement of two separate waves, X and Y. Wave X has frequency F and amplitude A. What is the frequency and what is the amplitude of wave Y? If we note that it's telling us that wave X, which is this wave here, is F frequency and A amplitude. Well, if it has an amplitude A and it's going up 1, 2, 3, 4, 5 squares, 5 divisions, they don't really give us what each one of these is, but it's like 5 units of displacement. We could see that wave Y goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has twice the amplitude, right? 5 compared to 10. So what is the frequency and the amplitude of wave Y? Well, right away, it's easy to see that the amplitude of wave Y is 2A, twice as displaced, twice the maximum displacement. So the maximum displacement is 5. Wave Y has a maximum displacement of 10. Almost like another wave X that was coherent came and met up with it and constructively interfered. And so, but that would be like if another wave met right here, then the resultant would be sort of right there at that point in space, right? This is another wave that sort of has a phase difference with it a little bit, right? So here is the 90 degrees phase for that. This wave isn't at 90 degrees of phase until sort of this point, when this wave is already at 180 degrees. So these waves are out of phase with each other, but they also don't have the same frequency, right? What's the frequency of this wave compared to wave X? Well, if we look at sort of the wavelength, we can see that this one goes, it starts here and then it repeats 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 20 units long, its wavelength. If we look at wave Y, it's 20 units long by the time it's half a wave. And so it is 40 units long. The wavelength of wave Y is 40 units long. So then we say, okay, if its wavelength is twice as long, it's going to occur half as frequently, right? So if we're standing here at this point and we're letting these waves pass by us, and we sort of click a button every time the crest of the wave passes by, instead of the wave moving past us, we'll just sort of move past the wave. This wave would sound like click, 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 click. But this wave would go click, 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 right? Half is frequently occurring because its wavelength is longer. It takes longer to get to the next crest. And so if it has twice the amplitude, but it's half the frequency, right? And so you have to sort of get both of those ideas correct to note that the correct answer to this is D. So they're not coherent because they don't have the same frequency, right? The waves have to have the same frequency if they're going to interfere, so that they keep on sort of meeting. And we can't apply the principle of superposition, and we could say when two waves sort of meet in space, the resultant displacement is the algebraic sum of the individual displacements, but we wouldn't see this sort of interference pattern. Okay, so we apply the principle of superposition, but only when the waves are coherent will we get interference, right? An interference pattern. And these waves are not coherent.